In this next video, we're going to talk about the area of regular polygons. First, we need to know what a polygon is. A polygon is any closed figure having 3 or more sides, and no sides can cross each other. A regular polygon is all sides of equal length and all angles of equal length. We're going to take a look at a couple examples and non-examples of basic polygons, not regular polygons. So an example of a basic polygon is this first one. Notice that we have 1, 2, 3, 4, 5 sides there. It's a closed figure and no sides cross each other, so that's an example of a polygon. And our second example here is just a basic triangle. We have 3 sides, they don't cross each other, so that's an example of a polygon. Our first non-example of a basic polygon is that as shown there. So notice that we have 2 sides and it's not a closed figure. Our second non-example of a basic polygon is that straight line there. We only have 1 side, however, we don't have a closed figure there, so that's not an example of a polygon. Notice this final example there. It looks like a bow tie. So although it's a closed figure, notice that the sides cross each other, so that's a non-example of a polygon. A type of regular polygon we're going to look at is called a regular pentagon. A regular pentagon has 5 sides of equal length. Notice the figure that I just inserted. It's clearly a pentagon, and each side is of equal length. Each side is 10 centimeters long. Now the trick is, how do we calculate the area? Well, if we compose this pentagon into a nice rectangle, we can calculate the area of the pentagon. Take notice at the rectangle on the outside of that pentagon. And also take notice that we have 4 different types of triangles on the outside of that pentagon. Well, we know how to calculate the area of a rectangle. That's just base times height. What's the base of our rectangle? Well, our base is 3 centimeters plus 10 centimeters plus 3 centimeters. We'll multiply that by our height. Our height is 9 centimeters plus 5 centimeters. We need to evaluate 3 centimeters plus 10 centimeters plus 3 centimeters. That is 16 centimeters. We need to evaluate 9 centimeters plus 5 centimeters. That is 14 centimeters. So now we multiply 16 centimeters by 14 centimeters, and that gives us the area of the rectangle. 16 centimeters times 14 centimeters gives us 224 centimeters squared. Now, that's the area of the rectangle, but we need the area of the pentagon. That's where the area of triangles comes in. So, now, notice that the area of the bottom 2 triangles is going to be 2 times 1/2 times 9 centimeters times 3 centimeters. Again, we're going to multiply that by 2 because we have 2 equal triangles on the bottom left corner and the bottom right corner. So 2 times 1/2 becomes 1, and we just multiply 9 centimeters times 3 centimeters, and that gives you 27 centimeters squared. And that's going to be the area of the bottom 2 triangles. Next, we're going to calculate the area of the top 2 triangles. So, we're going to multiply 1/2 times 8 centimeters times 5 centimeters by 2, because we have 2 triangles of equal length. If we multiply 2 times 1/2, notice that 2 times 1/2 gives you 1, and we simply multiply 8 centimeters by 5 centimeters. 8 centimeters times 5 centimeters gives you 40 centimeters squared. And that's the area of the top 2 triangles. Next, we're going to add the area of the bottom 2 triangles to the area of the top 2 triangles. So 27 centimeters squared plus 40 centimeters squared gives you 67 centimeters squared. And we're going to need this for our next thought. So, we're going to find the area of the pentagon. The area of the pentagon is just going to be the area of the rectangle minus the area of all triangles. Well, the area of the rectangle was 224 centimeters squared, and we're going to subtract 224 centimeters squared by 67 centimeters squared. And if we do that, we will get 157 centimeters squared, and that's the area of that pentagon. We're going to take a look at another type of regular polygon, and that's called a regular hexagon. A regular hexagon has 6 sides of equal length. Here's a picture of the type of regular hexagon we're going to look at. It's going to have 8 centimeters in length all around. Just as we did for our regular pentagon, we're going to do the same thing as a regular hexagon. We're going to compose that regular hexagon into one rectangle. We know how to calculate the area of a rectangle. That's just base times height. In this case, our base is going to be 4 centimeters plus 8 centimeters plus 4 centimeters. Our height in this case is going to be 7 centimeters plus 7 centimeters. We'll evaluate 4 centimeters plus 8 centimeters plus 4 centimeters, and that gives us 16 centimeters. We're going to multiply 16 centimeters by our height, and our height is just 14 centimeters. We just added 7 centimeters plus 7 centimeters to get 14 centimeters. And 16 centimeters times 14 centimeters gives us 224 centimeters squared, and that's the area of the rectangle. Take a notice at the rectangles on the bottom left, bottom right, top left, and top right corner of the rectangle. Notice that the triangles are all the same, and we know how to calculate the area of a triangle. In this case, the area of the triangle is going to be 1/2 times 4 centimeters times 7 centimeters. But we want the area of all triangles. In this case, since all triangles are equal, we're going to multiply the area of just one triangle times 4. We multiply the area of one triangle by 4 because all the triangles are of equal length, and we have 4 equal triangles. And if we multiply from left to right, we will get the area of all triangles as 56 centimeters squared. So we take the area of the rectangle minus the area of all triangles to find the area of the hexagon. And the area of the hexagon will be 224 centimeters squared minus 56 centimeters squared. That gives us 168 centimeters squared, and that's the area of the hexagon. Next, we're going to take a look at the final type of regular polygon we'll look at. It's called a regular octagon. A regular octagon has 8 sides of equal length. Notice the regular octagon that was inserted. Each side is 4 centimeters long. Just like we did for the last type of regular polygons, we're going to compose this octagon into a rectangle. Here is that octagon composed into a rectangle. Notice that we also have 4 types of triangles on the bottom left, bottom right, top left, and top right corner of the rectangle. We know how to calculate the base and our height of our rectangle. Our base is going to be 3 centimeters plus 4 centimeters plus 3 centimeters. We're going to multiply that by our height of our rectangle. Our height of our rectangle is going to be 3 centimeters plus 4 centimeters plus 3 centimeters. We're going to evaluate what's inside our first parentheses. That's 10 centimeters. We'll evaluate what's inside our next set of parentheses. That's also 10 centimeters. So we'll multiply those two values together to get 100 centimeters squared, and that's the area of the whole rectangle. Next, we'll calculate the area of just one of the triangles. Notice that the area of one of the triangles is just 1/2 times 3 centimeters times 3 centimeters. And since all of the triangles are of equal length, we can multiply the area of one triangle by 4 because we have 4 equal triangles there. So multiplying from left to right, we get 18 centimeters squared as the area of all the triangles. And in closing, we'll find out the area of the regular octagon is just the area of the rectangle minus the area of all triangles. The area of our rectangle is just 100 centimeters squared, and we'll subtract that by 18 centimeters squared. And 100 centimeters squared minus 18 centimeters squared gives us 82 centimeters squared. And that's the area of our regular octagon.